So, in today's lesson, we'll be discussing the topic in line of grade 8 fourth quarter, which is proving inequalities in a triangle. By the way, class, I am teacher Alex, and before we continue the discussion, we will be stating the objectives. And the objectives of this discussion is to use inequalities involving angles and sides of a triangle. So theorem 5 to 10, if a triangle is isosceles, then the largest angle lies opposite the longest sides, and the smallest angles lies opposite the shortest side. So in example 1, list the angles from smallest to largest. And as we can see that in the figure shown in the right bottom of the screen, we can say see the triangle XYZ with the correspondent unit of each sides. So the question in example 1 is list the angles from smallest to largest. So smallest angle to largest angle. So by the definition, uh, the largest or the smallest angle lies opposite the shortest sides. So as we can see, what is the where is the or what is the shortest heights in the given figure? So 17 degrees, right? And it is sides xy. So what is the opposites of side xy? Correct. It is angle z. Next is 29 degrees, which is side xz. What is the opposite angle of side xz? Correct, angle y. And lastly, the largest angle is the opposite of the largest sides, which is 32 degrees, which is angle x. So theorem 5 to 11 or converse of theorem 5 to 10. So 5 to 10 states that if the longest angle that must lies opposite to the longest sides and the shortest angles must lies to the opposite of shortest angles, right, sides, right? So here in 511, theorem 5 to 11, if a triangle is scalene, then the longest side lies opposite to the largest angle and the shortest sides lies opposite the shortest angle. So in example 2, in triangle QRS, list the sides from smallest to the largest. So list smallest sides to largest sides. So as we can see again in the bottom right of the screen, we can see that the figure Q or triangle QRS has one given, which is the value of angle Q, which is 30 degrees. And class, recall the properties of a triangle. So triangles must overall value of 180 degrees, right? So as we can see in a triangle, there is a right triangle, um, acute triangle, and obtuse triangle. Right triangle is 90 degrees. Acute triangle is less than 90 degrees, which is 45 degrees, and obtuse angle, it at obtuse angle is greater than 90 degrees or 180 degrees, right? So as we can see, it is the right triangle, and therefore angle S there is 90 degrees since it is the right triangle. So to add it up, 90 degrees and 30 degrees, we can now conclude that angle R is 60 degrees. So the question lists the sides from smallest to largest. So the smallest um, angle or the shortest angle, the smallest angle here is angle Q, right? So what is the opposite of angle Q? It is sides SR. So sides SR is the correct. Next is 60 degrees. What is the opposite sides of angle R, which is 60 degrees? Yes, sides SQ. or QS. And lastly, the largest angle, which is 90 degrees, and the opposite sides is angle QR. Mm, nasabtan guys? Ay class? Okay, good. So in example 3, in triangle TUB, which sides is the shortest? And to find the measure of T, we must use triangle to sum of the triangle to find the measurement of angle T. So as we can see in the given that angle U is 58 degrees and angle V is 62 degrees. And again, as we all know that the overall value of a triangle is 180 degrees. Okay? So now we can now conclude that if we add 58 degrees to 62 degrees, it is equal to 120 degrees. And we all know that 180 degrees is the overall value of the triangle. So subtract 180 degrees and to 120. So therefore, we can now say that the measurement of angle T is 60 degrees. And therefore, angle U is the smallest. And therefore, sides VT is the shortest. Since angle U angle U is the opposite sides of these shortest sides, right? So move on to next example, a theorem, which is theorem 5 to 12, the triangle inequality theorem. So it states there that the sum of the length of any two sides of a triangle is greater than the length of the third sides. Therefore, in example 4, can a triangle have sides with a given length? Explain. A. Uh, Given of 3 feet, 7 feet, and 8 feet. And B is 3 centimeter, 6 centimeter, and 10 centimeter. Who can answer letter A? None? So as we can see, it is yes. Since 3 plus 7 is greater than 8. And because 3 plus 7 is 10 feet is greater than 8 feet. So yes. So in letter B, it is obviously no, since 3 plus 6 centimeter is equal to 9 and it is less than 10 centimeter. So last example, a triangle has sides of lengths 8 centimeter and 10 centimeters. Describe the lengths possible for the third sides. So the solution, let x be the length of the third sides. And we all know that the sum of any two sides must be greater than the third sides. And it states in the theorem 5 to 12. So there are three possibilities of this problem. First is x plus 8 is greater than 10 and transpose 8 to the right side. So x is greater than 10 minus 2, which is x is greater than 2. Or x plus 10 is greater than 8. And if we transpose 10 to the right side, which is in the 8, we can now say that x is greater than 8 minus 10. And x is greater than negative 2. And last possibilities is 8 plus 10 is greater than x. And 8 plus 10 is equal to 18. So 18 is greater than x, or x is less than 18. So x must be longer than 2 centimeters and shorter than 18 centimeters. Therefore, x is greater than 2 and less than 18. That's all.